Today is 15th January 2026, and today we are starting a topic that is called total internal reflection. And in this topic, consider this is a tank of water, and there is a torch. There is a torch inside the water, and this is the light ray. Actually, the bulb or lamp is here, and the light from the lamp, this is called incident ray. But today, the lamp is inside the water, and this is incident light ray. And this is the boundary or surface of water. In the last class, we have studied, sir, when light travel from water into air, from glass into air, then the light cannot go straight. The light bends, and you can see the light is bending away from the normal. The light is bending away from the normal. This is angle I, that is incident angle. Consider this incident angle is 30 degree. And for this 30-degree angle, the angle of refraction in air, angle of refraction in air, angle of incidence is in water, angle of refraction in air, consider this angle is 54 degree. Consider this is a 54-degree angle. Okay. And if I ask you to change the position of lamp, if I ask you to change the position of incident lamp, when you change the position of incident ray, it means you have increased angle I. Consider now the incident angle is increased to 35 degree. And when you increase incident angle, then you will see angle of refraction in air will further increase. Consider angle of refraction in air is 73 degree. It means if you are increasing angle I in water, it will increase angle R in air. Then I ask further to increase this angle I, further increase angle I. And when you increase this angle I, consider now this angle I, consider now this angle I is 42 degree. If the angle I is 42 degree, consider the angle of refraction, the angle of refraction becomes 90 degree. The angle of refraction becomes 90 degree. Incident angle 42 degree, angle of refraction 90 degree. And this angle of incidence is called critical angle. This angle is called critical angle. So when you increase angle I in a denser medium, you know, water is a denser medium, air is a less denser medium, water is a high density medium as compared to air. When angle I in denser medium is increased, then angle R in air also increase. And at a certain incident angle, angle of refraction becomes 90 degree angle. And this incident angle is called critical angle. So I am writing some few sentences here. Note down. When angle I is increased in denser medium, when angle I is increased in denser medium, then angle R further increased, further increased in air. You are increasing angle I, then angle R further increasing in air. And the key word is the incident angle, the incident angle. It is the definition of critical angle. The incident angle in denser medium, the incident angle in denser medium, and do not write. I will share you this PDF, okay? The incident angle in denser medium at which the angle of refraction becomes 90 degree. The angle of refraction becomes 90 degree. It is called critical angle. It is called critical angle. So I'm repeating and Navia will explain me. Okay, what did I explain? What did I say? Sir, in this example, the lamp is inside the water. The lamp is inside the water. Sir, when light incident on the water surface, it is emerging out into the air. The lamp is inside the water. When the light incident on the boundary, it is emerging out into air. Sir, when you are increasing angle I, angle R further increasing. When you are increasing angle I, angle R further increasing. The incident angle in denser medium. When angle of refraction becomes 90 degree, this angle is called critical angle. Navia Beta, can you explain what is critical angle? Navia Beta, can you explain what is critical angle? Hmm, hmm, hmm. बेहतरीन बेहतरीन नविया ने बहुत अच्छा समझा दिया भाई जबरदस्त हो गया अच्छा बेटा एंड यू नो कि when the light is traveling from water into air then the formula of refractive index is sin r divided by sin I. We have studied this formula in the last class. And for today, if the angle R becomes 90 degree, if angle R becomes 90 degree, then incident angle is not a simple angle. So this angle is called critical angle. So here C is the critical angle, but I think this C may confuse you because C is the speed of light. But remember, small c is the speed of light. Small c is the speed of light, and I should write especially capital C. And the capital C stands for critical angle. And you know, if you use calculator and if you calculate sine 90, then sine 90 is 1. Sine 90 is 1. So we will use this formula today. We are going to use this formula today for total internal reflection, and you should note down this formula. But Amna and Faria, you should note down this formula. We will use this formula in today's class. N again, refractive index. And the equation of refractive index, yesterday we studied sine R upon sine I. And when angle R is 90 degree, then obviously angle sine 90 कैसे 1 हो गया? Okay. Amar, if you open calculator and you write sine 90, sine 90. Ammar, what is in your calculator? Sine 90 is equal to 1. Okay, beta. So the value of sine 90 is 1. Okay. So this is the sine 90 is equal to 1. So today's formula is 1 upon sine C, and this is the basic definition of critical angle. And in this example, critical angle was 42 degree. But if you increase further incident angle, consider the lamp is situated here. Consider the lamp is here. Sir, if the lamp is here, then the light will not exhibit refraction. The light will exhibit total internal reflection. Now you can see this black ray is inside the water. The black ray is inside the water, and this black ray is exhibiting total internal reflection, which I should write TIR. TIR for total internal reflection. TIR for total internal reflection. And if you go into your group, then I sent you few interesting videos. Look at this video on the YouTube. I think it is running. This is a tub of water. This is refraction. In this video, you can see there is no mirror. There is no mirror, just water inside the tank. This was the tank, and the teacher used a laser light, and the laser light is striking with the boundary of the water, and then it is exhibiting total internal reflection without mirror, the light exhibiting total internal reflection. And I did not write the definition of total internal reflection. I explained critical angle. I explained critical angle, and now I am going to write, sir, when incident angle increased beyond critical angle. This is critical angle. This is critical angle. And when you cross critical angle, okay, when incident angle exceeded to critical angle, then the light does not exhibit refraction. Now the light exhibit total internal reflection. So the final sentence I am writing here, and then we will start past paper question. When incident angle, when angle I, incident angle, is greater than critical angle, when incident angle is greater than critical angle, then light ray exhibit total internal reflection. Okay, so this is the definition, and now we are starting questions from past paper sheet. This is the past paper sheet which I have extracted some questions from past papers, and the question number one is June 2016, paper 42. And in this question, what is meant by critical angle? So we have discussed critical angle, so I am not wasting your time. And now I'm solving this question. Beta Faria, Beta Faria, I am talking you, Faria, calculate critical angle and you are given refractive index. Can you tell me, Faria, what is the formula between critical angle and refractive index? Faria, can you tell me what is the formula between refractive index and critical angle? Yes, sin 90 के बजाय 1 upon sin c. Okay, so 1 upon sin c. Okay, because sin 90 value of sin 90 is 1. So you should use only this formula. N is equal to 1 upon sin c. N is equal to 1 upon sin c. And you have to calculate critical angle. So I am taking reciprocal on both sides. Reciprocal on both sides. So if you take reciprocal, then sin c is equal to 1 upon n. Reciprocal both side. Mathematics, reciprocal on both side. Okay. And now I am putting the value. The value of refractive index is 1.56. The value of refractive index is 1.96. You have to calculate C. So this sign becomes sine inverse. This sign becomes sine inverse. And now I am using calculator to show you how to calculate sine inverse. So if you press shift sign, it becomes sine inverse. Then I'm writing 1 divided by 1.56. Then the answer is 39.86 means 40 degree. Means 40 degree. So the value of critical angle for this question is 40 degree. Okay, but this is a question for June 2016, paper 42. In this question, you are given refractive index and you have to calculate critical angle. Okay, and now I'm solving the next question. The next question is a ray of light in glass. It means the lamp is inside the glass. The lamp is inside the glass. The question is if the angle I is less than critical angle. If the angle I is less than critical angle. Sir, if angle I is less than critical angle, then no total internal reflection. Sir, there will be refraction of light. There will be refraction of light. When angle I is less than critical angle, then there will be refraction of light. And if angle I is greater than critical angle, if angle I is greater than critical angle, then what happens? So the answer is, sir, there will be total internal reflection. Total internal reflection. Sir, when angle I is less than critical angle, there will be refraction. If angle I is greater than critical angle, then there will be total internal reflection. Okay, so we have discussed this condition and now we have a mathematical part, mathematical question. And for this mathematical question, I should ask a question with Amna. Amna, can you talk me? Amna, are you there? But Amna, I think Amna microphone is not working. But Rafe, but Rafe, if I draw a normal at B. If I draw a normal at B, and this is the incident ray, this is the incident ray, then what is angle of incidence? Then what is angle of incidence, Rafe? 60. Because this angle 30 is not with normal. The angle with normal, it is called angle I. It is called incident angle, and the incident angle is 60 degree. Rafe replied, sir, it is 60 degree angle. Acha beta Rafe, the critical angle is 41 degree. Critical angle is 41 degree. If incident angle is greater than critical angle, then what happens at point B? Rafe, what happens at point B? Sir, there will be total internal reflection. Reflection. For reflection, if the angle on the left hand side is 60, then the angle at right hand will also be 60. So at 60 degree angle, you will draw a ray, and this is total internal reflection. This is total internal reflection. Okay, but the question is you have to leave the glass. This ray you have to draw leaving the glass. So, beta Faria, can I talk you? Beta Faria, can I talk to you? Yes, I am asking you if I draw a normal here. If I draw a normal here, consider this point is C. Consider this point is C. What is this angle at point C? What will be angle at C? What will be angle at C? Beta, this is a right angle triangle, and in this right angle triangle, you can see, sir, if Amar, you are right. Amar, you are right. If if this angle is 60, then this angle is 90. Yes, then this angle is 30. I ask you this question. Okay. If this is the right angle triangle, then obviously angle at C is 30 degree. Okay. And if this angle is 30 degree, then this 30 degree is less than critical angle because the critical angle is 41 degree. जी बेटा फारिया, can you answer me? हाँ बेटा, this angle is 30 degree बेटा, and this angle is measured 30 degree. How? So I am explaining the sum of angle, the sum of angle in a triangle. What is the total sum of angle in a triangle? That it is always 180 degree. You know, the total angle is always 180 degree. So if I write x this number, then 60 plus 90 plus x is equal to 180. And if you solve for x, then x will be 30 degree. Or simply, sir, if this is a right angle triangle, in a right angle triangle, you can calculate third angle very simple. The difference of these two angle will be the third angle. 90 minus 60, the third angle will be 30 degree. जी बेटा फारिया, is it clear? Okay. And this angle is 30 degree, which is less than critical angle. And if this angle is less than critical angle, then there is no total internal reflection. Sir, here will be refraction. And refraction means the light will emerge out into the air and bending away from the normal. This is the original path. Light will not follow the original path, not bending towards the normal. The light will bend away from the normal. The light will bend away from the normal. So this is the emergent light. This is the emergent light, and it will be better for you after my class. You should draw these angles. You should practice these mathematical questions because I am sending you videos. So I think you should practice yourself by drawing these diagrams. So this diagram is completed. And now the final question is here. Calculate refractive index of the glass. Refractive index of the glass. And you are given critical angle. You are given critical angle. Okay. So, beta Faria, do you know any formula which relates critical angle with refractive index? Faria, n is equal to 1 upon sine c. Okay. C is the critical angle, and critical angle in this question is 41 degree. Critical angle is 41 degree. And if you use calculator, then in calculator, if you write 1 divided by sine 41 degree, then the answer is 1.52. Okay, so the angle is 41 degree and the answer is 1.52. Ji Ammar beta, you are right. Acha beta, Amna, why Amna not participating in the class? Amna beta, are you in class? But I think Amna microphone is not working. हाँ beta Amna, you do not answer beta, you do not answer me. Okay, okay, okay. And now we are solving the next question. The next question is here. Question number 48. Question number 48. Question number 48 is explain what is meant by total internal reflection. What is meant by total internal reflection? So I am writing the answer. The answer is what is meant by total internal reflection? Answer is when angle I is greater than critical angle. When angle I is greater than critical angle in denser medium. In denser medium, light reflects back in the same medium. In the same medium. Okay, when angle I is greater than critical angle, then you know the light will exhibit total internal reflection and the light reflects back in the same medium. Ji Rafe. Yes, this is the answer key. The answer key is in the marking scheme, reflection in a denser medium when there is no refraction. Okay, all the light in a denser medium is reflected. Okay, in this question, in this marking scheme, there is no explanation. This is point to point answer. That is why I copy pasted marking scheme as well. Okay, ji? So you should write this answer. But right now I am teaching. That is why I am writing in more wording. I am writing more wording. WTTE means I will tell you बेटा हमारा भी अभी आपको बताता हूँ रुकिएगा अच्छा जी reflection in a more dense material. Dense material means medium. Denser medium. Reflection of light in more denser medium when there is no refraction. Okay, so you can write these words as well. And now the next part is, sir, what is critical angle? What is critical angle? We have discussed, sir, critical angle means the incident angle at which angle of refraction becomes 90 degree. The angle of incidence at which angle of refraction is 90 degree. It is called critical angle. So I have shown you marking scheme as well. And now we are solving a mathematical part. अच्छा बेटा, Faria, I am asking you, and I have taught you in the last class. This is a boundary of prism, and this is the incident ray. This is the incident ray. Incident ray is striking at 90 degree. Incident ray is striking at 90 degree. When light incident at 90 degree, then there is no change in direction. There is no change in direction, and light goes straight. Light goes straight. If the light is striking at 90 degree, if the light is striking at 90 degree, the light goes straight. Okay. And now, if I draw a normal here, draw a normal on the boundary. This is the boundary of prism. This is the boundary of prism, and this is the normal. And this is angle I. This is angle I. But Navia, can you tell me what is angle I here? Navia, but can you tell me what will be the angle I here? Navia, can you answer what is angle I? Okay. But Faria, can you tell me what is angle I? I think Rafe, तुम बता सकते हो what is angle I? Yes, it is 30. It is 30. And why it is 30? No, 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 no. It is not 30. रुक जाइए. It is not 30. नहीं 30 नहीं है. फिर कितना फिर बताओ राफे. राफे बता सकते हो? ठीक है. जरा सुनिए. Right now, yeah, yeah, yes, yes. Right now, I have drawn a blue right angle triangle. I have drawn a blue right angle triangle. In this right angle triangle, this is 90-degree angle, and 90 minus 60, so it is 30-degree angle. And if it is 30, then obviously angle with normal, because this is normal, angle with normal is called angle I. Angle I is 60. Angle I is 60. And in this question, they are asking, by draw, draw without calculation. Okay, we have done calculation. Draw carefully without calculation the continuation of the ray, the continuation of the ray through the prism and into the air. And you are given critical angle is 42 degree. You are given critical angle is 42 degree. Acha ji, right now you can see this angle I is 60 degree and critical angle is 42 degree. You are given 42 degrees the critical angle. If the critical angle is 42 degree, angle I is 60 degree, and you can see incident angle is greater than critical angle, so there will be total internal reflection. And for total internal reflection means light will reflect here. Light will reflect here. At 60-degree angle, at 60-degree angle, light exhibit total internal reflection. Light exhibit total internal reflection. And finally, if I draw another normal here, if I draw another normal here, then light will emerge out into the air. And you know, when light emerge out into air, then it bends towards the normal or away from the normal. Sir, in air, it bends away from the normal. In air, in air, light bends away from the normal. Light bends away from the normal. So I'm revising the question. Sir, this is incident ray at 90 degree, it is going straight. Sir, this is incident ray 90 degree, so it is going straight. At this point, angle I is 60, and this 60 is greater than critical, so there will be total internal reflection. So I drew this reflected ray. At this point, I draw another normal, and now the rays emerge out and bending away from the normal. So the question was, draw carefully the ray. It is a 3 mark question of drawing. So I have explained you the whole drawing. And now we have a question. We have a question. And the question is, calculate refractive index, and you are given speed of light in air divided by speed of light in glass. And they are asking calculate refractive index. So refractive index is equal to speed of light in air divided by speed of light in glass. Speed of light in air divided by speed of light in glass. And if you simplify these numbers, then the answer is 1.5. The answer is 1.5. Okay, by speed of light, we have calculated refractive index. And now we have another question. The question is calculate critical angle. Calculate critical angle. You know, n is equal to 1 upon sine c. N is equal to 1 upon sine c. And if you are calculating sine c, then sine c is equal to 1 upon n, reciprocal of both sides. Then sine c is equal to 1 upon n. And if you are calculating critical angle, then it becomes sine inverse 1 upon critical, sorry, 1 upon refractive index. Refractive index is 1.5. Refractive index is 1.5. And now if you calculate critical angle, then I think it will be 42 degree. Critical angle will be 42 degree. So by speed of lights, we calculated refractive index, and the refractive index is used to calculate critical angle. So this question is also completed. Marking scheme is also attached, so you can see. And now question number 27. Now question number 27, October, November 2021. This is again a prism, and in this question, this is the boundary, and on this boundary you have to draw a normal. Okay, this is the boundary, and on this boundary you have draw a normal. And the question is make measurement. Make measurement. So you have to measure this angle. You have to measure this angle by using protractor. Okay, but I cannot measure, so I should take help from the marking scheme. The angle is 60 degree. This angle 60 degree is by measurement. Okay, this is angle by measurement. So angle of incidence is 60 degree. The question is determine the angle of refraction of this ray when it strike face AC. अच्छा अभी AC पे भी strike करना है इसको. ठीक है, ठीक. Accurately draw the path of the ray within the prism from face AB to face AC. You will need to make a measurement and carry out calculation. Okay, and refractive index is 1.5. Refractive index is 1.5. Refractive index is 1.5. Okay, and this is a 4 mark question. This is a 4 mark question. Okay, so when you measure this angle is 60 degree. You are given refractive index. Abata Faria, can you help me? Can you tell me the formula? What formula should I use to calculate angle of refraction? Angle I we have measured. Angle I we have measured. Angle R we have to calculate. Give me the formula. जी नहीं. 1 over sin c is used when there is total internal reflection. Here is no total internal reflection. The light ray is in air. The light ray is in air, and the light ray is entering into the glass. जी. आप हमें डरा रही है बेटा, इतनी आसान सवालों को आप नहीं कर पा रही बेटा. When there is total internal reflection, then 1 upon sin c, and here is simple refraction. So angle I is 60 degree. Refractive index is 1.5. Refractive index 1.5. Sine angle I 60 degree. 60 degree is measured by protector, and you have to calculate sine R. You have to calculate sine R. You have to calculate sine R. So then this sine R with 1.5 interchange their position. Sine R is equal to sine 60 divided by 1.5. Sine 60 divided by 1.5. And if I use, okay, but I think I should show calculation. So I am showing you calculation sine 60 and divided by 1.5. So the number is 0.577. 0.577. So sine R, after sine R is 0.577, and then angle R will be sine inverse 0.577. राफे अब मेरी हेल्प कीजिए, क्या एंगल बनेगा बेटा? राफे बेटा व्हाट इज 35.3? ठीक है, 35 डिग्री लिखा हुआ आंसर. सो द एंगल आर इज 35 डिग्री. ठीक है बेटा. तो in this question they ask to measure angle I by protector and calculate angle R by formula. Angle I by measurement and angle R by formula. And when you have calculated angle R, that is 35 degree, then you have to draw this 35 degree angle inside the prism. So this is the original path. This is the original path, which is at 60 degree angle. But you have to draw, you have to draw a line which is making 35 degree angle, 35 degree angle with the normal, 35 degree angle with the normal. This angle should be 35 degree, which you have calculated. You have calculated and you have drawn. You have calculated and you have drawn. And I should reduce the size of the normal. So this is the normal line. Sir, why did you reduce? Because I have to draw another normal here. Read the question. The question is determine the angle of incidence on face AC. Face AC. This is face AC. On this face AC, you have to determine this angle. And this angle you will measure by protector. This is very small angle. This is very small angle. And this angle you have to measure. You have to measure. Okay. And in the marking scheme, the answer is 10 degree. So this 10 degree by measurement. Okay, beta. This 10 degree by measurement. This 10 degree by measurement. Without formula, by measurement, you can measure angle I on the face AC. So this question is completed, and now the question 1 mark for further. Uh, Path of ray through the face AC. Okay. So you have to draw further ray. And this ray, when enters into the air, sir, it will bend away from the normal, not towards the normal. It will bend away from the normal. Not calculation, without calculation. You have to draw the ray which is emerge out from the prism. So this is the incident ray. Inside the prism, it is refracted, and after the prism, it is emerging out. After the prism, it is emerging out. So I have drawn its path. And now the new topic is optical fiber. The new topic is optical fiber. Sir, what is optical fiber? But Afaria, do you know what is optical fiber? Do you know what is optical fiber? हाँ बेटा? No, okay. I am explaining you. Optical fiber, all these questions are about optical fiber. In our daily life, we use wires or cables for electricity. And for electricity, the wire is made of copper wire. So this black line is a copper wire, and around the copper wire, there is a thick insulation. This thick insulation sometimes is of rubber or plastic or cloth or different material which are insulator. Okay, and this copper wire is a good conductor of electricity. So electricity enters from here and leaving from here. And these copper wires was used for telecommunication, for telephone, etc. But nowadays, these copper wire are replaced by plastic wire. This is a plastic wire or a glass wire. Okay, this is a wire of plastic or glass which is transparent. Which is transparent. This central layer which I have drawn with blue color, it is transparent material. Transparent means through which light can pass. So this is a transparent material. Okay, and in this transparent material, light is entered. And when light enters into the optical fiber is a transparent wire, and through this wire, light can pass. And when light enters, then the light exhibit total internal reflection. This is the situation which you are given in an exam question. This is boundary of optical fiber. This is boundary of optical fiber, and within the boundary, this is the light ray. This is the light ray, and this light ray enters into the optical fiber, and the light ray exhibit total internal reflection. This is the incident ray, and these rays, the same ray exhibiting total internal reflection. Okay, so optical fiber is a wire which can carry light, and in this light there will be total internal reflection. And how does total internal reflection is used in optical fiber? I will share you some videos in your group, and you must watch these videos. If you do not watch, then obviously you cannot visualize what I am saying. So in the next class is on Friday, Saturday. But remember, on Tuesday, Wednesday, Thursday, I will continue this topic which we are studying. Tuesday, Wednesday, Thursday, we will continue the same topic. But Friday, Saturday, there will be class. There will be class. But the same topic will not be running because two students of grade 9 students will be taking class on Friday, Saturday, and I will take I will teach another topic with them. But you have to join that class as well. Okay. So Tuesday, Wednesday, Thursday, we will continue the same light topic. But on Friday, Saturday, there will be another topic. And I think I will teach them um, general properties of wave. General, जी बेटा, general properties of wave.